Uh, Good afternoon. This is my project, midterm project for wireless communication systems. Today my topic is 5G system evaluation tool. My name is Abul Khair Fanwar, and let's begin with. First of all, I want to slightly touch the development of the networks and explain what is the 5G itself is. 5G is a telecommunications system, is the fifth generation technology standard for cellular networks, which cellular phone companies began deploying worldwide in 2019. It is the planned successor to the fourth generation networks, which provide connectivity to most current cell phones. In this table, you can see the pluses and how the network's development throughout the history. And 5G right now is the current most usable network. Oh, sorry, not right now is 4G, of course, but 5G is like our future for it's also starting development like years ago. But my topic is about the system evaluation, and today I want to start with a plan, what is consists from introduction. Next is features of 5G system evaluation tool, evaluation results. What is the I will show you. I will talk about the example what I found in one of the China cities, and also conclusion. First of all, introduction. Utilization of the 600 GHz bands is investigated for the 5th generation mobile communication system. To increase the system capacity, because these bands have possibility of assignment of a relatively wide band, and in the high frequency bands, multiple antenna technologies such as massive MIMO and beamforming are used to compensate for the increasing impulse loss due to high frequency usage. Also, development of 5G system evaluation tools that evaluates the 5G propagation characteristics and system performance in various areas based on computer simulation. The tool itself calculates propagation characteristic using ray tracing and the throughput based on Shannon capacity using the obtained propagation characteristics. What I will show down there, we will see the equation using Shannon capacity theorem. This report describes the full function and presents evaluation results. Okay, features of the 5G system evaluation tool. The 5G evaluation system tool features the capability to calculate changes in CINR and through output due to changes in the direction of the beamforming antenna pattern. Through output is calculated based on CINR, which is calculated based on ray tracing simulate result of the evaluation target area. Each function of the tool is explained in the following selection. The picture is showing the two different type of radio propagation calculation and system evaluation, what we will be touching in down there, and it's also spread out for different areas and fields, what we will be slightly touch in the following examples. Radio propagation propagation calculations. A radio propagation model comprises a static structure model such as a building and terrain model, which is generated based on a map database, and moving objects model, such as that for cars and humans' bodies and other movable objects. The moving objects model is same as the UTR channel model, in which cars and human bodies are defined as metal plates. Also, user can set an arbitrary place size to the moving object. Basically, the tool adopts array launching method for radio propagation calculation. However, knife edge diffraction is applied to calculate the blockage loss due to the moving object, in the same way as the ETR air channel model. The picture is showing just bold examples how the field is covering the some of the area with built-in cars, and also signalize different connections. Next is system evaluation. The antenna pattern generation is prepared to evaluate the Zener through output using beamforming antenna patterns that are calculating using a set number of antenna elements and also intervals between the elements of uniform planar array. This is a picture of the example of uniform planar array. To begin with, this equation based on the Shannon capacity is, first of all, let's describe this table. It's calculation flow of Zener through output. This will be the 3 steps of calculation, like the first of all, decision of connecting BS, decision of optimal antenna pattern for BS and MS. Also, we have 2 options like downlink and uplink evaluation, what is lead us to Zener through output calculation, and there will be the result is next. First step is a decision of connecting between BS and MS. This step decides which BS is connected to MSX. In this flow, MCX connect to BCX, from which the downlink received level is maximum. In the calculation, the BS and MS antenna patterns are static and the antenna pattern can be set by the user. Second step is the selection of optimum antenna pattern, what is we will be deciding between BS and MS optimum antennas. This step decides the pattern for BSX and MSX when beamforming is available for the BS and MS. The optimum beam pattern is a combination between the BS and MS antenna patterns that generate the maximum received level. And the next step is third step, what is the Zener through output calculation. And the Zener through output calculation of the selected link is when it's calculated, both the up and down links can be selected. This section describes the downlink case. After the Zener is obtained, the through output can be obtained by plugging the Zener into the equation based on the Shannon capacity theory. Moreover, the received level of the desired wave is given by the radio propagation calculation, results an optimum antenna pattern selected in step 2. And the noise level is given as a constant with the related parameters. First, expect BSX is connected to only one MS if there is only one BCI, except BSX. The source of the interface BSI and MSI, which is connected to BSI. MSI is selected randomly within the meshes that are set in the first step of the simulation. If beamforming is selected in a simulation setting, user can choose 2 ways of beamforming direction control for BS and MSI. One is the random direction and the other is optimum direction, which is the same as in step 2. And now, by submitting the Zener base of the above procedure into the following equation based on Shannon capacity, we can see the formula right here, and it's through output T in bits seconds. In this equation, A is the coefficient considering the overheat of the transmission signal. between BV is band switch in here layers, and beta is coefficient of the sinner that is decided by the number of layers MIMO streams. And Y is the maximum bit per symbol that is decided by modulation method. And as described in the above, this tool generates selection of interfering MSS, the direction of the beamforming antenna patterns of interfering BSS and MSS, and the status of the uplink or downlink of TDD as random process. The tool evaluates stochastic characteristics of the sinner and through output by interacting step 1 to 3 for an arbitrary link between BSX and MSX. Moreover, moving objects such as the cars and human bodies can be deployed as a random process, therefore stochastic characteristic can be evaluated due to changes in the surrounding environment. And now I'm going to talk about evaluation results. What we will be touching is shows area through output evaluations in Chonggu, Tokyo at 28 GHz. ABC is established on 3 sectors markets, the through output, like these 3 BC stations, and expressed by heat map, and each through output value is the average from 100 event on each MS site. Through output in the line of the site environment is higher than the non-loss environment from the calculation result in this paper. Only a simple example that has 3 BSS is shown. However, realistic BS deployment cases will be studied in the future, because right now their calculation is not sufficiently correct. And then we will be going to conclusion. It's about features of the 5G system evaluation tool and evaluation results in Tokyo. Using this tool are presented. This tool evaluates the system's potential when dynamic beamforming and TDD are adopted. Therefore, more realistic evaluation can be obtained than from existing evaluation tools. However, they are different between the evaluation methods of the tools and actual system in terms of the interfering MS selection and beamforming controls. Anyways, therefore, the improvements on these points are targets for the future's work and studies. And this is all for my presentation. Thank you for your attention.